Hi, welcome to Unit 5, Day 6, Types of Chemical Reactions, Synthesis and Decomposition. This is part 1 where we'll focus on synthesis. So last week we learned about chemical reactions, and we said a chemical reaction is a process where chemicals known as reactants are mixed together to form different chemicals called products. And we sort of related this to cooking, where reactants are like the ingredients that you use when you're cooking. You mix those together, and the products are like the food that you make at the end. We also looked at different signs for chemical reactions. So things like if there's a temperature change or gas is being made or produced are indicators that a chemical reaction has taken place. Now, these are observable signs. Sometimes a chemical reaction can take place and you won't observe these things, but a lot of times you will see some sort of one of these signs. This week we're going to learn about the types of chemical reactions. And there are 5 basic types of chemical reactions: synthesis, decomposition, combustion, single displacement, and double displacement. Now, that's a lot to cover all in one day, so we're going to split this out throughout the week. And if you want to pause, you can see the video to see our schedule. Today, Monday, we're focusing on synthesis and decomposition. And there are several items for success for today. So first, be able to explain why it's helpful to be able to identify the type of reaction. Next, be able to identify if a reaction is synthesis, decomposition, or neither. We'll also practice balancing chemical equations. And finally, we'll be able to express a chemical reaction equation in words. So why is it helpful to be able to identify the type of reaction? Why do we need to know the 5 types? So if you know the type of reaction, there's a couple things that you can do. One, you can predict the products from the reactants and vice versa. For example, if I told you that methane, CH4, was undergoing combustion, what are the products? Knowing that it's a combustion reaction, you would know the products would be CO2, carbon dioxide, and water. The other thing we'll be able to do is, if you know the type of reaction, is use strategies to balance chemical equations based on the type of reaction. Okay, so we're focusing today on synthesis and decomposition. Synthesis means to combine, and decomposition means to break down. So these words aren't random. They actually are based in the definition of these terms. So based on the definitions that you see here, I'm going to show you 2 sets of reaction. Set 1 and set 2. These reactions are not balanced, and that's just for clarity purposes. But I want you to use the definitions that you see above to see if you can identify which set is synthesis and which set is decomposition. Pause the video now. When you press play again, the answer will be revealed. Great, so set 1 is decomposition and set 2 is synthesis. So you may be able to figure that out just from the definitions. But if not, we're going to deep dive a little bit further, starting with synthesis. So here are examples of synthesis reactions. Now, synthesis means to combine. And in a synthesis reaction, you're combining 2 or more types of reactants to make one type of product. So if you look at all of these examples here, you have 2 types of reactants like CO and O2, and they form to make one product, CO2. And we can sort of hash that out in this example here. So I also showed you a particle diagram of CO and O2. They can combine to form CO2. And remember, what you're starting off with are your reactants, and then there's your products. So in a synthesis reaction, the things that you're looking for is 2 or more types of reactant, and key thing, you should have one type of product. All right, so looking at these examples below, I want you to identify which one is synthesis reaction and explain. Once again, these reactions are not balanced, and that's for clarity. So pause the video now. When you press play again, the answer will be revealed. Okay, the answer to this is B. And the reason why it's choice B, remember a synthesis reaction, you have 2 or more reactants, you start off with 2 or more things, and you'll make one type of thing in the end. And so the only answer that fits that is choice B. Choice A only has 1 reactant, so it cannot be a synthesis because you need 2 or more reactants. And choice C and D, they have two types of products. So for a synthesis reaction, you only need one. You can only have one type of product. All right, so now what we're going to do is we're going to sort of do a little throwback review. This is the synthesis reaction from the previous question, previous CFU. I want you on a separate piece of paper to balance this. Now, if you need a hint in about 3 seconds, I'll give you a hint. But if you don't need a hint, you can go ahead and pause the video now and start working on it. All right, so if you need a hint for getting started, remember when balancing chemical equation, the first thing you want to do is list the number of atoms on both sides of the arrow. So we have 1 nitrogen here, and we have 1, 2, 3, because there's 2 O's and 1 O over here, so a total of 3 oxygen on the reactant side. And then you do the same thing on the product side, so 1 nitrogen and 2 oxygen. Then what you're going to do is you're going to change the coefficient, which is the number in front, until you have the same number of reactants same number of atoms, it should say, on both sides. So pause the video now. When you press play again, the answer will be revealed. Great. So here's your answer. You'll notice that you should have a coefficient of 2 in front of NO and a coefficient of 2 in front of NO2. And there's an invisible 1 in front of O2. And this is the particle diagram that also shows its balance. So in order for it to be balanced, you have the same number of atoms on both sides. And you can see from the balanced chemical equation and the particle diagram, we have 2 nitrogens on both sides, and we have 4 oxygens on both sides, and that's why it's balanced. All right, so I just want to emphasize here that the coefficient in front of O2 is an invisible 1, not a 0. Coefficients cannot be 0. And finally, if you want to see this work done out, there's an extra help video in the Schoology folder. All right, so in the first set of examples, I gave you unbalanced equations, and that sort of makes it easier to figure out something is a synthesis reaction or not. But what if you were given a balanced equation? If I gave this equation to you as is and asked you to determine if it was a synthesis or not, using the definition, you may be a little confused. Because you may be thinking a synthesis reaction has 1 product, but this one has 2. There's a coefficient of 2 in front, so there's 2 products. So what's up with that, right? How do you figure that out? The key thing is that in a synthesis reaction, it has 1 type of product. So even though there are 2 NO2s, there's still only 1 type, right? They're both NO2s, it's just 1 type of product here. So how would you deal with it if I gave you a balanced equation with coefficients in the front and asked you to identify what it is? The best thing to do is just to ignore the coefficients. So those coefficients that you see there, just sort of blend them out of your mind. Just ignore them, or you can cross them out there on a piece of paper and focus on the definition there. So again, for a synthesis reaction, you have 2 or more reactants and 1 type of product. All right, that is it for part 1. And part 2, we'll talk about decomposition. Have a quality day.